Welcome back. Today we're going to be talking about area of squares and rectangles. So the first thing we want to do is just look at the basic introduction to area and what it's kind of telling us. And so area is the space inside of a square. So before you talked about perimeter, which is the length on the outside, well, area is now talking about the inside. So on the very top of the page, we have two examples with some smaller squares inside, just to help us visualize what area actually is. So if we were pretending that each of the smaller squares represented 1 centimeter, we could quickly look at this and calculate what the area of that rectangle on the left is. So we can do that. We can just quickly go and count them off. So we can start on the left-hand side here. We can go 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7, 8, sorry. So 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. So we could say that the area of the first one is 40 centimeters. Now, it's not centimeters by itself, it's centimeters squared. Now, that's one way of doing it, is counting them all. However, that's not the most efficient way. So you will notice that when we first counted this bottom line, we got 8. So 1, 2, 3, 4, 5, 6, 7, 8. 8 centimeters. And if we count this top line, 1, 2, 3, 4, 5, we'll get 5 centimeters. So the distance between here and there is 8 centimeters, and the distance from here to there is 5 centimeters. And if you know your multiplication table, you'll know that 8 times 5, or 5 times 8, is 40 centimeters. So we can create a formula based on this, and we can say that the area of a rectangle is equal to the length times the width. Now, a lot of students will ask, well, which one's the length and width? In reality, it doesn't matter. When we're dealing with rectangles, it doesn't matter which order you multiply the numbers in. With any multiplication problem, it doesn't actually matter. Okay, now the next one on the right is a similar size shape, but we have to look at it a little bit differently. So you'll notice that it's missing a part. It's missing a section from here. So we can calculate the area of this shape by counting up the squares inside. So we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32 centimeters squared. But you'll notice that if I had initially done my 8 times 5, I would have gotten an answer of 40 centimeters squared. I would not have gotten the true area with 32 centimeters squared. So I want to keep that in mind when we come to some later questions, that we have to do this question a little bit differently to solve and find out what the area of this part is. Okay, so let's go and try to complete this first question here, which is just applying that area formula. So the area formula is, again, area is equal to the length times the width. So in here we have our area is equal to our length. We'll say the length is 9 centimeters multiplied by our width, 4 centimeters. Now 9 times 4 is 36. We can't figure out our units. But there's a problem here. I can't just write centimeters. I need to go and change that number somehow. Now what I've actually done is I've multiplied centimeters by centimeters. I've multiplied 9 centimeters times 4 centimeters. So when I multiply centimeters times centimeters, what I actually end up getting is centimeters squared. If I was doing a problem and I had centimeters times centimeters times centimeters, I'd end up getting centimeters cubed. And you'll notice that this is how we represent volume, and this is how we represent area. In volume, we multiply 3 measurements together, Well, in this case, we only multiply two measurements together. So we have to include that little centimeters squared on the very top there. Okay, so moving on to some more difficult problems. We're just going to look at these two here. Now, you'll notice that this shape that we've got here is, you can view it as either one or two rectangles that are combined together, or potentially looking at it as one big rectangle missing a section. So how you view this shape is going to determine how you choose to solve it. Now, there's two different ways of doing it, and I'm just going to show you both ways, and whatever works best for you, we can do. So the first method I'm talking about, I like to call it combining. So what we're going to do is we're going to actually divide this big shape into two smaller shapes and then combine it at the end. So what we're going to do is we're actually going to divide and work with two different shapes. We're going to work with shape number 1 and shape number 2. So first we need to do is calculate the area of shape number 1. So shape number 1, our area is going to be our length, which in this case is 6 centimeters, multiplied by our width, which in this case is 4.1 centimeters. Now, if you have a calculator at home, you can go about and use it, or you can calculate this all on your own, but you will get an answer of 24.6 centimeters squared, which is this amount right in here, 24.6, I forgot that 0.6 centimeters squared. Now, shape number 2. Shape number 2, we have our 2.1 centimeters here, 2.1 centimeters multiplied by 2.5 centimeters. And we calculate that this one comes out to 5.25 centimeters squared. So 5.25 centimeters squared. Well, that's the area of each of those. Now what we have to do at the very end is add them together. So we need to add up shape 1 plus shape 2. And shape 1 we said was 24.6 centimeters squared. We're going to add that to our 5.25 centimeters squared, which gives us a final answer of 29 and 85 hundredths centimeter squared. So that method, we divided this shape up into two parts and then combined it at the end. Now, another way of doing this is to pretend that this is all one giant shape. So we're going to pretend that this is all one giant shape. And then at the end of our operation, we're going to take away, subtract this portion. So that's another way. So we're going to pretend that this big one is shape number 1, and that this little one is shape number 2. So to calculate your area of the first shape, we're going to use our length and our width. Now we can't use this measurement here because it only goes from here to here. We actually have to use this bottom measurement. So we get 6.2 centimeters, this measurement right here, multiplied by 6 centimeters. And that gets us a value of 37 and 2/10 of a centimeter squared. Now to calculate our area of shape number 2 here, we actually are missing a measurement. We're missing this distance right here. We know this is 2.1 centimeters, but we don't know how long that is. So to do this, we can actually use our measurement on this side, 6 centimeters, and we can subtract 2.5 centimeters, this distance from it, to figure out what our distance right there is going to be. So I'm just going to do this calculations on the side here. To find out that distance, we have 6 centimeters subtracted by 2.5 centimeters, and we get in the end 3.5 centimeters. So I'm just going to write that down right in here, 3.5 centimeters. So now we have our length and our width. So area of shape number 2 is going to be 3.5 centimeters multiplied by 2.1 centimeters. And that gives us 7 3/5 centimeters squared. Now again, when we did this problem, we calculated the entire area of this big shape, and then we said we're going to subtract this smaller shape from it. So in this case, we're actually doing shape 1 minus shape 2. And so we have to take our value, 37 2/10 centimeters squared, and subtract from that 7 3/5 centimeters squared, which gives us a final answer of the exact same thing, 29 85 centimeters squared. Now it doesn't matter which method you choose to use. Either one is perfectly fine. It's whatever you feel most comfortable with. All right, thank you for watching.